Hi, in this video, I will be demonstrating our tool OSATE-DIM. OSATE-DIM is an incremental solution for the instance model view update problem in AADL. OSATE-DIM stands for OSATE-Declarative-Instance Mapping, where OSATE, which is the open source AADL tool environment, is the reference tool for AADL, where AADL is the architecture analysis and design language. The contributors and developers for this tool are myself, Rakshit Mittal, Dominic Blouin, and Soumyadi Bandyopadhyay. This tool is the result of a collaboration between Telecom Paris, France, and BITS Pilani, India. The outline for this demonstrative video as follows. First, I will be introducing AADL, its reference tool OSATE, the problem at hand, which is the view update problem for AADL, and finally our solution, which is OSATE-DIM. Then I will be describing the installation procedures for OSATE-DIM. OSATE-DIM supports three scenarios: state-based deinstantiation, in-place incremental deinstantiation, and out-of-place incremental deinstantiation. I will be demonstrating all of these three scenarios. Out-of-place incremental deinstantiation is not fully implemented, but I will be describing parts of it. Finally, I will be describing the repositories where the source code for OSATE can be obtained from. On the screen right now, I have the AADL 2.0 reference manual documentation. The AADL has been standardized by the Society of Automotive Engineers, also known as the SAE. It is a textual and graphical language used to design and analyze the software and hardware architecture of performance-critical real-time embedded systems. The AADL is composed of two metamodels, the declarative metamodel and the instance metamodel. The declarative model allows for a rich specification of various component inheritance hierarchies, containment hierarchies, and property inheritances. This is achieved through various levels of abstraction for component definitions, through component types, component implementations, subcomponents, and etc. The instance metamodel or the instance model is derived from the declarative model. A system instance represents the runtime architecture of an actual system that consists of application software components and execution platform components. Essentially, the instance model is a flattened view of the declarative model. The instance model does not contain any of the inheritance hierarchies, but only represents the containment hierarchies and the property definitions for each component locally. This allows for easier analysis of the system at hand. Since the instance model is derived from the declarative model, it is also known as a view of the declarative model. I will now be describing the installation procedure for OSATE-DIM. The web link given in the manuscript redirects the user or the reader to this web page. Click on installation. So I assume that the user has already installed OSATE. You can either download it directly from this link, or you can install it into an existing Eclipse workspace using these two steps. I assume that the user has already performed these steps, and I will be demonstrating the next step, which is installing OSATE-DIM. OSATE-DIM can be installed from its update site. So you copy the update site webpage link. You go to your Eclipse installation where you want to install OSATE-DIM. Click on Help, Install New Software. I paste the update site web link and I click. So I see OSATE-DIM here now. I select OSATE-DIM. Next, wait for Eclipse to compute requirements dependencies. Okay, so we are good to go. I click Next. I accept the terms of the license agreement. I click Finish. So now Eclipse is installing OSATE-DIM, as you can see from progress bar. So now OSATE-DIM has been installed. You need to restart your Eclipse IDE to effect or apply the software updates. As you can see, I have my Eclipse IDE restarting. And if I go to the AADL perspective, I should see the OSATE-DIM toolbar right here. You can also see the DIM deinstantiate menu. from the OSATE toolbar menu. So now that we have OSATE-DIM in our Eclipse workspace, I will now be describing or demonstrating the actual tool itself. For this, I have taken the test cases from the test suite which we have developed for OSATE-DIM. This is the test package from the repository. And as you can see, we have two test examples, which one is the MCDAG and the other is the Ramses refinements. MCDAG is taken from the MCDAG tools test bench, whereas Ramses has been taken from the Ramses tools benchmark suite. Both of these tools have been developed by our group for CSD at Telecom Paris, so you can check them out as well. So we start with the first case, the first scenario, which is the state-based deinstantiation scenario. In the state-based deinstantiation scenario, we have one instance model, and we want to generate a corresponding declarative model for this instance model. So I select this instance model, and I click StateDim from the toolbar, from the OSATE-DIM toolbar, or I can go into the OSATE menu. Deinstantiate or state, or I can also in the AADL navigator right click on the instance model which I want to deinstantiate, click dim deinstantiate and select state. So these are a few different ways by which you can do it. You can also do it using you can also click on the system implement or the system instance itself and click on the button. So I do that, and correspondingly, if you see, so now the state-based instantiation is occurring, the tool is working correctly. And as you can see, a new declarative model has been generated here. This new declarative model, if you look at it, will have its correspond to the instance model which we described here. So similarly, you can use as you can see, we have main IMPL and all these different, so it has two subcomponents, proc and CPU. Proc is a process subcomponent and this CPU is a system subcomponent. Similarly, for subcomponents, you have CPU and proc. And as you can see by this question mark, this file has been newly generated. So this was state-based deinstantiation. You can similarly do it for the Ramses example as well. So now that I have described the state-based deinstantiation case to you, let us now go to the second scenario, which is the in-place incremental deinstantiation. So this is the instance model which I have. Maybe I regenerate it. So this is the declarative model which we have here. These are the declarative specifications. I right click, instantiate, I instantiate main.impl. So instantiation is successful. This is the corresponding instance model. Maybe I open them side by side so we can visualize it better. Okay, so I will now select the instance model which I want to deinstantiate incrementally. This is the instance model. I click incremental in place deinstantiation. So incremental in place deinstantiation is started. Now I select, suppose the change which I want to make is I want to, so incremental in place deinstantiation is working at the moment. Synchronization is on. So I go to, suppose I want to change the name of this process subcomponent, which is proc, to let's say proc1. I mean, just an example. So I go to properties for proc and I go to proc1, save, and correspondingly, if you see, this process subcomponent's name has changed to proc1. Similarly, I can make various other kinds of changes as well. All kinds of changes are supported. So now that synchronization is running, if the user wants to stop the synchronization, you can simply press the third button, which is stop incremental in place dim, and that stops the synchronization transformation. And so these are the two scenarios which I've described. The third scenario, which is the out of place deinstantiation scenario, is still under development, but we have already developed a delta trace model for um, scenario. So maybe I can describe the model here. So we have this eCore model. The delta trace model is basically a trace model which logs differences between two instance models, an old instance model and a refined instance model. So the trace spec contains all the traces. The trace spec specifies which is the right system and the left system. So the right system is the refined system instance, and the left system is the old system instance, which is being refined. So, and it contains traces which are called Excel to Excel traces. So this is the Excel to Excel trace element. So the right instance, left instance are the respective AADL elements which are being correlated. And then we have three entities or features which are called objects to attach, object changes, and objects to detach. These concepts have been borrowed from EMF change, and you can look up more documentation over there. So objects to attach simply identify which objects have to be attached to the left instance. Objects to detach identifies which objects have to be detached from the left instance, and object changes describe property changes or e-property changes in the left instance, which result in a right instance. So this is the delta trace model. We will soon be releasing deinstantiation, out of place deinstantiation, which also uses the delta trace model. So be on the lookout for that. So this was with the demonstration for OSATE-DIM for the two scenarios plus the delta trace model which I've described here. Now I will be describing the repository, the Git repository. So the code is hosted on a GitLab repository. I'll just log in. You can, if you have credentials using Shibboleth, you may log in, or you may contact either me or Dominic if you need access to the GitLab repository to access the code. And this is the OSATE-DIM project. We have the delta trace models here, and we have the test projects, the UI, the transformations. So yes, this is the this is our tool OSATE-DIM. Let us know if you have any comments and doubts. Do read our paper, our manuscript, which is under review right now. So thank you and have a nice day.